Okay, thank you very much. It's really nice to be here and be able to speak to the big data side of Data Portal. And thinking back to Ian's definitions, I think I quite like your definition, Ian, the one at the end. And I think that DPUK really wants to try and take the vagueness out of big data, and through various, through our data curation and our training program, hopefully that we are working towards ramping up the, as Paul says, the variety, volume and velocity of big data and its potential. So this is the front end of the data portal. This is the front-facing end that researchers can see on our website, where they are invited to discover, access and analyze large cohort data. We like to think of the data portal as a one-stop shop, where suddenly we have democratized data access, whereas up until now a researcher had to maybe go a long way round and have funding behind them, have a top institution behind them to apply for just one data set. And feedback from people over the last couple of days, it takes ages to apply just for one cohort. But now with just one application, a researcher can apply for multiple data sets for appropriate research questions. So how do we do it at DPUK? Well, the first thing that we do is we help researchers identify cohorts of interest for their research question. Not only is this good for the researcher, but it's also good for the data owners who've entrusted their research, their data to DPUK to repurpose it for dementias research. And so we offer the Cohort Matrix, which is a quick overview where researchers can come along and have a look at our cohorts on the left. They can see size at baseline, and they can also look at presence and absence of data within the 18 categories of our data model, which I will get to later in my talk. Armed with this information and having identified top-level cohorts for their research question, they can then move on to the Cohort Directory, which is a more granular directory or provider of information where they can then click into their cohort of interest to see more about that cohort and to see the type of data that the cohort has collected. And here we can see an example from the ELSA cohort. So a researcher who wants to do longitudinal modeling, for example, can have a look at that specific variable of interest and exactly which waves it has been collected so that they can really target their application. So once a researcher has gained access to at least one of their cohorts, so that means, so what happens is they apply, comes through a brief scientific review, and then it goes out to our cohort owners. DPUK does not own the data. We do not have the final say on who accesses it. The cohort owners maintain this. And when they have permission to access just one, even if they've applied for 10 cohorts, we provide them information on how to download VMware onto their laptop or their desktop. They have a two-step login process, and then they have access to this wonderful desktop. And it has all pre-installed statistical software packages, and that's everything from MATLAB to R, Stata, SPSS, and Jupyter Notebooks. And so it in no way differs from if they had their data set on their desktop at home or at work on a hard drive. The only difference is they cannot download the data from the data portal, and they also have no access to the internet, but that doesn't stop us enabling the download and upload of packages and extraction of output for publication and presentation purposes. Data curation, moving on. What is the need for data curation, and why has DPUK really invested so much into this area of big data? And I really want to thank ADDI for supporting this area of DPUK and investing resources to push forward our data curation program. My team, my data curation team, is sitting at the back of the hall, and they work every day on trying to categorize data So on the left here, we have an example, and I want to give credit to Dr. Ulrich Barsch of Surrey University and the DRI. He's running a large sleep study on DPUK, and he's listed the cohorts and how they name just the variable ID. And you can see it just is, the variety is huge. On the right-hand side, where you can see the variable, have you ever had a pain in your chest? And across 3 cohorts, it's been named incredibly vague and incredibly different. So the CSERV data model, John Gallagher came into my office back in October 2017 and said, Sarah, we've got to organize our data according to some data model. It's so huge, it's so vast. He says, go and find one. So I got on the train, I traveled all over, I ran workshops, and we came back and we came to the conclusion that there simply wasn't a data model for heterogeneous cohort data. So he says, let's make one. And so this is it. It's the CSERV data model. It has 18 top-level categories. Underneath this is 160 second-level categories, over 700 third-level categories, and at the variable level, there is anything between 23 and 50,000 unique variables across DPUK cohorts. So this is the structure of an example of a variable. Again, I've gone back to, have you ever had a pain in your chest? So the top category, or the theme, would be medical history. The domain would be self-report medical history. The family, pain self-report. And then finally, the object level. We have renamed this into pain chest ever. I think it's a little bit more intuitive than just F_051. And so this is really our structure. And if you think that we're doing this for every variable across every cohort, this is really a labor of dedication. And when I presented on this back in 2018 at AAIC, people just looked at my giant 2-meter poster and said, you're mad. But now we're doing it, and I think we're making good progress. So a common confusion is what's the difference between standardization and harmonization. Now, standardization is to standardize it to a common naming structure so that if a researcher sees, have you ever had a pain in your chest in one cohort, it will be named the same across 5 cohorts. But harmonization is actually standardizing or harmonizing down at the variable level, the data level. So in other words, depression across 5 cohorts might be measured incredibly differently. So when you try to standardize this to a common structure, that's known as harmonizing. And the place that we do that is for our Cohort Explorer tool. We have 30 variables selected across neurodegenerative disease, and we harmonize them for this tool for feasibility analyses and for data visualization. So this is what we term harmonization, and that could be converted to perhaps a Z-score, a cut point, or simply the whole score, such as MMSE. So one of the realizations we came to really quickly, although the data portal has become incredibly popular, 900 users, multiple applications across 40-odd countries, researchers, it's really a new beast to work with big data sets with their variety and their volume. And so we realized that if we're going to provide a data service, we need to provide affordable, accessible training focused on big and multi-cohorts. So we started about 5 years ago with our datathons, and we have 6 cohorts who've signed up for this initiative and allowed us to use their data. So researchers come along. Pre-pandemic, it was in person. During the pandemic, we went to online, and we'll probably stay online because we have further reach. They come for 5 days. We divide them up into groups according to ability, institution, and the only background they need is some statistical analyses. And they get to interrogate the data over 5 days according to a research theme, perhaps comorbidities of dementia or cognitive decline. And then on the 5th day, they present their progress. And it's fun, it's popular, and we also mentor them then for the next 3 months, hoping that a preprint will come out of this. And we have a few successful groups who have either published or in the process of publishing because of datathons. We also have the researcher training academies. We have the Spring Academy for analysts who have no experience of analysing data. We take them through from identifying cohorts of interest, variables of interest, to correlation to regression analyses. And then we have the Autumn Academy, and this is more experienced analysts, and we teach them sophisticated longitudinal methods for cohort data. Again, it's not just a generic analyst academy or a course. It is really focused on large multi-cohort data. And then finally, we're just launching a new initiative. This is Specialist Methods Academies. And the first one is structural equation modeling, because that's my background, so it was an easy place to start. And this is a theory-driven approach. So Paul spoke about data-driven versus theory-driven approach. Not one is better than the other. I believe they need to be used together, and we need to teach researchers how to use these approaches together. So structural equation modeling is theory-driven. You bring to it your theory, you build your model with latent constructs, observed variables, outcome variables. You'll see some of the posters today included these models. So we have I run a 2-hour workshop with a brief introduction of this is structural equation model, this is how you interpret your model, and then we are also going to be running a specialist working group for more advanced users. And coming next is survival analyses and machine learning. So we're also I introduced at the ECR morning a researcher hub, and this is really to complement the work of Dementia Researcher by Adam Smith and AR UK's Researcher Hub, because what we want to do is set up mentoring, and I'm appealing to all of you right now, this is a pitch, sales pitch. We would really like mentors for this mentoring hub, and you don't have to invest a lot of time. We're looking for senior academics with an area of interest, a scientific focus to mentor the next generation of early career researchers, so do contact me if you are interested. We have a community forum for them. We have information on data portal, neuroimaging, genomics, and uncategorized for new and emerging themes. So this is our service to the community we're serving through big data. And now I'm going to have to be really quick because I've been shown the sign. So we believe that DPUK really does offer multimodal science. This is a researcher I supervised who took raw image data, pre-processed it on the data portal, and extracted out her IDPs to look at early adversity on well-being and cortical atrophy. And what we found was a decrease in the size of the caudate nucleus and putamen with increased adversity, and a decrease in well-being with increased adversity. DPUK also offers multi-method science. With the size of the desktop, it could be 8 gigabytes for regression modeling or 128 gigabytes with 16 CPUs. There's my geeky coming out. And that really suits multi-method science. So bringing, in this example, some psychometrics with item response theory modeling, extracting out that theta measure, putting it into a complex structural equation modeling. Because it's done on the right desktop, it's totally possible. And then multi-cohort science. This study by Ruby Sang across Whitehall, Health and Retirement Study, and Carme study. The studies were very diverse, very different, but looking at different classes of cognitive trajectory and the effect of early life on those trajectories. The measures didn't have to be the same, they didn't have to be harmonized, but by validation in large cohort data, it is incredibly powerful science. What you find in one population, and if you find consistency in another, that is really powerful. And then these are the posters we've got up today. Just a pitch for those 2 posters. I'm happy to say Morgan actually won a prize. I wasn't biased, I stepped out of voting. Thank you very much.
Thank you, Sarah. That was absolutely brilliant. Questions? On the lights? Maybe I could start with asking you one. I mean, Are there plans to add more cohorts to this already impressive collection? And if so, how long does that kind of thing take?
Well, at the moment we have 60 cohorts across 3.5 million individuals, and we're certainly not turning away cohorts. We would very, very, very much like to open discussion with new cohorts, diverse cohorts, especially clinical cohorts, and data which is perhaps sitting in a box under someone's desk. So very much welcome to expanding on our data corpus.
Very good, thank you very much. There was a question there.
Good evening. Fantastic talk. I think you do so much great job on this, because I recall we did this for the genetic studies, and then we were trying to harmonize a variable like smoking, and we ended up the harmonization yes, no, because that's the only thing that harmonized. So that's also my question. So where do you draw the line that you start losing information that may be relevant, or I guess you always keep the raw information, but it's a very delicate balance, isn't it?
Yes, it is, and that's why we only do harmonization for data visualization. For the rest of the cohort data with standardization, that is why it's really time-consuming, because that example I gave with did you ever have a pain in the chest? If one cohort has said, have you ever had a pain in the chest when you walk uphill? That variable has to be named and categorized differently. So yes, we always refer back to the raw data label, and the work is cross-checked by about 3 of us. So if one has a subjective interpretation, we make sure that that is standardized. So yes, we have to incorporate that variety.
Any more questions? Just trying to make sure I haven't missed any hands. John? It's bound to be hard.
It's bound to be horrible.
No, actually, I'd just like to follow up on Cornelia's question. Harmonization, we really restrict our harmonization for data discovery purposes, because one person's harmonization for one hypothesis is another person's nonsense for a second hypothesis. And so we think if we can provide standard data structures to help people discover the data, give people the option to use the standard data structure or the raw data structure, that way we're not limiting their academic freedoms at all, but just harmonize so that they can find the data easily and get a feel for it easily. That is the best compromise, I think, that we are willing to do, because to put a lot of effort into bespoke harmonizations used by few is not a good use of time.
Yeah.
Thanks, John. Any further questions? Simon's got us back on track with his signs. Thank you very much, Sarah. Great talk.